Coolant delivery is from admart.com Pay Products website. This is a training presentation, audio, video, and the actual download comes with an audio attached to the download, as does all the products downloaded from admart.com. The software will allow the user to input their present grinding process and determine what is needed for GPM and PSI to achieve optimum coolant delivery relative to the present wheel velocity. The sheet has been completed and we will review together the input. The input sections are gray colored in charcoal cells as follows. Coolant type. This is the first choice at the top of the page, and the user has a choice of water or oil. Anything that is synthetic or water soluble, you will need to choose water only. Straight oil, you will need to choose oil from the drop down box. The choice has been preset to water, so let us change to oil. You will notice that the PSI in red will change from 45 to 39. We'll go back to the water. The software has been developed for using multiple nozzles, both round and rectangular. The user has the following choices. If rectangular and one nozzle, the height of that nozzle should be entered. If multiple rectangular nozzles, the average height of all the nozzles would be entered. Again, if only one rectangular nozzle, then the entire length of that nozzle would be entered. If multiple rectangular nozzles, the average of the length of all the nozzle openings would be entered. If the nozzle is round, the diameter of the nozzle. If multiple round diameters, the average of all the diameters would be entered. Then the user must input the nozzles for each design, round or rectangular. In this example, we have 4 rectangular nozzles and 1 round nozzle. There must be at least one number entered for one rectangular nozzle and input at least one entered for any round nozzle been entered. The next input is the grinding wheel RPM. In this case, that has been entered at 43.72 and the wheel diameter at 4.3 inches. Thus, calculated to a wheel velocity of 4,922 surface feet per minute. Let's change the wheel to say 5,000. You will notice what happens to the calculation. Every number below the actual measurement changed. We'll put it back to 43.72 and watch the screen again. The next input for the user will be the wanted velocity percent coolant that will be faster than the velocity of the wheel. This is important because for optimum results, the coolant should be a velocity at least 5% faster than the grinding wheel velocity. I will input 5%. You can put any number you wanted. And if you left it with nothing, that reflects just 100% of that velocity. So we'll put 5% in and watch the numbers change. Now you notice everything changes down to this box because this is the actual measure. From all the input data above, the software will calculate the needed calculated velocity in inches per second, calculated flow rate in cubic inches per second, needed calculated coolant flow in GPM, and the calculated velocity or wheel velocity at 45, as you see here. Both of those are in red. So these are the calculated numbers from the previous calculated data. Note, PSI is always calculated from wheel velocity only, and GPM is relative to the nozzle area. Therefore, the more wheel velocity, the more PSI, and the more nozzle area, the more GPM. You always want the measurement to be close to the nozzle as possible. So this is where we're going down to the actual measurement. Any coolant that could be escaping, such as additional holes in the manifold that has not been plugged, will skew the numbers and the data will be useless. Also, if you measure at the pump, you are susceptible to head loss from the distance the lines are traveling from the pump, along with any changes in the diameter of the pump, other than straight line piping from the pump. Every 45 and 90-degree bend will also cause loss of flow and pressure. When all the numbers have been entered and calculated, the next step is for the user to measure both pressure PSI using a pressure gauge at the manifold of the nozzle and the coolant flow, either bucket test, assuming the flow is not too severe to make it impossible, or a flow meter will be attached to the manifold. So in this case, I have actually measured and put in 40 psi, which is obviously, as you can see, lower than what is recommended. And the actual measured coolant flow is 50, where we needed 98 based on these nozzle input. This is then telling me that calculated based on those numbers, we're only running 54% of the needed value. Now, if I were to go and input PSI at 45 and GPM at 98, 98, then you will see we're at 105. And the reason we are is because up here under velocity and coolant faster than wheel velocity, we entered 5. So let's take that out. And now we would be back to, we would be at 105, only because now, if you notice, the 98 has been moved to 93. So if we move this to 93, then we'd be at 100%. Again, we can go up, put in 10% this time. Now we're up to 102. If we were to change the GPM to 102, then you would see we would be at 110%, reflecting the 10% increase. When all the numbers have been entered and calculated, next step is to measure both the pressure and the gauge and the nozzle, which we just did. Those inputs will calculate the real numbers and compare those recorded numbers with the calculated numbers to give the calculated actual coolant velocity, inches per second, coolant relative to the calculated flow rate in cubic inches per second, and the actual percent of coolant relative to wheel velocity, that in this case with 10% came out to 110% if you had 102 GPM at 45 psi. Remember, to maximize your process, you need between 100 to 110% of coolant velocity relative to wheel velocity. At the bottom of the page is a conversion that I have added for your extra benefit. Let's just input 1 in the east number and you will notice the changes. We go 1 for millimeters, 1 for bar, 1 for meters per second, meters per minute, pounds per square inch, PSI, head loss, meters, wheel surface foot relative to nozzle needed, and kilowatt power. Please notice that because of the conversion factor, you will need to enter at least 164 under the surface foot right here because of the conversion. So in this case, we'll put 164, and you will notice it'll at least register 0.1 nozzle PSI needed. So to let you see how this calculates out, we actually had a grinding wheel velocity of 4,922 back up here on the top. So let's go ahead and put in 4,900 and what was it, 22. And as you're going to see, it comes out to 45.2, which rounded is 45 as indicated above. I would suggest you save these sheets as a PDF file by process and then clear the contents and start over for a new project or processes. If you have any problems or questions, please contact me, Dale Savington at admart.com, www.admart.com, under the Contact Us portion of any page. Please take the time to review the other products we have available on the Pay Products page on our website at admart.com. Thank you.